Welcome to the Dusty File, and today, is the void really empty? A question that seems simple at first, almost childish. Is space just a big nothing? But like all questions that appear simple, it is a doorway. A doorway into physics, philosophy, cosmology, quantum mechanics, and even the future of everything that exists. Tonight, we're opening a file that resists being closed, a file that grows the more we explore it, a file whose pages multiply as you read, a file titled The Void. But unlike ordinary files, this one refuses to stay finite. As we step into this dark space together, remember, darkness isn't emptiness. Silence isn't absence. Sometimes the quietest places are the ones doing the most. So take a breath, settle into the stillness, and let the universe unfold. When most people imagine outer space, they picture a vacuum so complete that absolutely nothing exists in it. A kind of perfect, absolute emptiness. But that image comes from human intuition, and human intuition is famously terrible at understanding things on cosmic scales. To understand the void, we must unlearn instinct and open ourselves to something stranger, something far more alive. Let's begin with the simplest piece of the puzzle: atoms. Even in the emptiest regions of the universe, there are still atoms, tiny particles of hydrogen or helium, drifting alone in an ocean of darkness. In some places, you might find only a single atom in a whole cubic meter. It sounds like nothing, but it is something. And something is enough to break emptiness. Imagine one hydrogen atom traveling through the universe for millions of years without hitting anything. It moves through darkness so complete that there is no heat, no pressure, no sound, no resistance, no direction. It simply goes, carried by momentum it gained billions of years ago. But even that lonely atom represents the universe's refusal to produce true nothingness. When we zoom out from atoms and look at larger scales, we discover more matter hiding in the void. Thin clouds of gas stretch across light years. Interstellar dust, tiny grains formed in the hearts of dying stars, drift through the galactic darkness. These dust grains contain carbon, silicon, iron, oxygen. Some contain organic molecules, amino acids, carbon chains, the building blocks of life. So the void is not a place without potential. It is a delivery system for the seeds of biology. That dust eventually becomes part of planets, comets, atmospheres, and oceans. Some of it lands on Earth in the form of meteorites. Some of it may even carry molecular recipes older than the sun itself. The void is not dead matter. It is the archive of cosmic chemistry. But as strange as dust may be, it is not the strangest occupant of the void. The void is filled with neutrinos, the ghost particles of the cosmos. Trillions pass through you every second without touching anything. They come from the sun, from black holes, from distant galaxies, from the birth of the universe. Neutrinos barely interact with matter at all. They pass through planets, stars, even neutron stars as if they were shadows. Imagine a universe where shadows cast other shadows. Neutrinos are like that, passing through everything, unstoppable and invisible. But even neutrinos are not the deepest mystery of the void. There is also dark matter, which makes up most of the matter in the universe. Dark matter does not emit light, doesn't absorb light, doesn't reflect light. It does not interact with electromagnetism at all, and yet its gravity shapes galaxies. It holds them together like invisible glue. Without dark matter, the Milky Way wouldn't exist. Stars would fly apart like sparks from a fire. Dark matter forms enormous cosmic structures, webs stretching across billions of light years. Galaxies hang from these filaments like beads on a string. If you could see dark matter, the universe would look like a vast, glowing spiderweb. But we can't see it. We walk through it every second, unaware. The void is full, but full of things we cannot detect with our ordinary senses. However, matter, both visible and invisible, is not the only occupant of space. There is also radiation, energy flying through the void at nearly the speed of light. Cosmic rays, for example, are high-energy particles from exploding stars and colliding galaxies. They can pass through spacecraft walls. They can pass through your body. Astronauts sometimes see bright flashes of light inside their eyes, caused by cosmic rays striking their optic nerves. Imagine sleeping in space and seeing flashes in perfect darkness. A storm without clouds, without sound, without warning. Now, let's talk about something more sensory, more human: the smell of space. Astronauts often say that after a spacewalk, their suits smell like burnt steak, hot metal, welding fumes, or sometimes like ozone. Space itself has no smell because there's no air. But when astronauts re-enter the spacecraft and oxygen touches the materials on their suits, a chemical reaction takes place. Radiation, vacuum exposure, and solar wind have created new molecules on the suit's surface. Those molecules interact with oxygen and bring that strange scent to life. So in a sense, the void leaves a signature behind, a reminder on a suit that you just walked through something that wasn't nothing. Most people think emptiness means silence, but the universe proves them wrong again. Black holes collide and send out gravitational waves, ripples in the fabric of space-time. These waves stretch and compress reality itself as they travel across billions of light years. Neutron stars vibrate like cosmic drums. Plasma in space creates electromagnetic waves that can be converted into eerie audio. The void has a voice. We just need the right instruments to hear it. Now step back with me. Leave the scale of stars and dust and neutrinos. Let's look at the largest structures in the universe: cosmic voids. These are enormous regions of space where almost nothing exists. They stretch across tens or hundreds of millions of light years. The largest known void, the Bootes void, contains only a handful of galaxies, where we would expect thousands. If the Milky Way were trapped inside the Bootes void, our night sky would be unimaginably empty. No dense star fields, no bright nebulae, no nearby galaxies, just darkness in every direction. And yet even these colossal voids are not truly empty. They contain dark matter. They contain stray hydrogen. They contain microwave photons from the early universe. They contain gravity itself, stretching out into the darkness. Even the biggest emptiness in the universe refuses to be nothing. Now imagine being alone in intergalactic space, far from any star or galaxy. You would see almost nothing. Space would not even look black, because your eyes rely on light to function. With too little light to detect, your vision would fade into a kind of perceptual silence. No sound, no air, no pressure, no heat, no orientation. Your body would not know which way was up. You could be spinning and never feel it. You could be accelerating and never notice. In this environment, your thoughts become the loudest thing in the universe. Astronauts experience a mild version of this called the overview effect, a sudden shift in consciousness when they see Earth from orbit. They feel small, yet deeply connected, humbled, yet inspired. Now extend that feeling. Remove the Earth, remove the Sun, remove the Milky Way, remove everything but darkness. The void becomes a mirror, a reflection of the self, a place where your mind fills the silence with meaning, fear, wonder, or understanding. The void is not just scientific. It is psychological. It is philosophical. And now, let's explore something I intentionally left shallow before: the future of the universe. Stars burn hydrogen to shine, but hydrogen is finite. Eventually, the universe will run out of it. Star formation is slowing down right now. In the far future, trillions of years from now, no new stars will form. Existing stars will burn out. Red dwarfs will glow dimly for trillions of years, but they too will die. White dwarfs will cool into black dwarfs, cold, invisible cinders. Galaxies will drift apart, pulled away faster and faster by dark energy. Eventually, distant galaxies will move so far away that their light will never reach us. The universe will become increasingly dark, increasingly cold, increasingly empty of the things we recognize as something. Black holes will dominate for a long time, but even they will die. Through Hawking radiation, black holes slowly leak energy. Over time periods longer than human language can describe, they evaporate. The universe then enters a stage called the black hole era, then the dark era, and finally, the degenerate era, when most particles decay or drift endlessly. But even then, the void will not be empty. Quantum fluctuations will remain. Virtual particles will continue to flicker. Entropy will hum faintly. Photons will travel forever through endless space. True emptiness may be physically impossible. The universe seems to reject the concept. Even its final state is not nothingness. It is a whisper, a faint flicker of energy, a trembling fabric of space-time, a quantum foam that refuses to stop. The void is not the absence of everything. It is the background that makes everything possible. And now, we return to the beginning. Is the void really empty? Not at the quantum level, not at the cosmic level, not at the psychological level, not at the philosophical level, not in the past, not in the future, not even in the end of time. The void is filled with dust older than stars, with ghost particles that pass through planets, with invisible mass that shapes galaxies, with radiation from ancient explosions, with structures larger than imagination, with chemistry that forms life, with the silent architecture of the universe. The void is full of everything we cannot see, full of everything we have yet to understand, full of the secrets that make reality possible. Thank you for opening this dusty file with me tonight. And until next time, remember, when you look into the dark, you are not looking at nothing. You are looking at everything the universe hides. Unless, of course, the story doesn't end there. Because if you're still listening, then you and I have slipped into the margins of the file, the scribbled notes, the underlined phrases, the ideas circled in red with a question mark. This is the appendix of the void, the part that keeps physicists awake at night. Let's pull the folder back open. We've talked about dust and neutrinos and dark matter, but all of that still lives on one side of a deeper divide. On one side, things, particles, fields, radiation, gravity. On the other side, nothing, or at least what we once thought was nothing. To truly ask whether the void is empty, we have to go beneath atoms, beneath particles, beneath even space-time as we usually imagine it, and step into the world of quantum fields. In modern physics, what we call empty space is not a stage on which particles dance. The stage is the dancers. According to quantum field theory, everything that exists is made from fields that fill all of space. There is an electron field, a photon field, a quark field, a Higgs field. Even when there are no actual particles present, the fields are still there. They cannot be removed. Imagine the universe as an infinite ocean. Particles are like waves on the surface, visible disturbances. But even when the ocean looks calm, it is never truly still. Zoom in close enough, and you find ripples, vibrations, fluctuations, tiny surges of energy that pop into existence and vanish again. This is the quantum vacuum, the void beneath the void. In this vacuum, nothing is not a blank zero. It has energy. It has structure. It can be polarized, twisted, excited. Two metal plates pulled close together in a vacuum can actually feel the restless nature of this nothingness. Between them, certain quantum fluctuations are suppressed. Outside them, more are allowed. The imbalance creates a tiny force pushing the plates together. We call this the Casimir effect, and it's one of the ways the universe quietly whispers, "I am never truly off." The void hums, even when everything else seems silent. Now here's where the void drifts from science into almost mythic territory. If the vacuum has energy, and energy curves space-time, then the vacuum itself can act like a kind of invisible pressure. In fact, one of the leading explanations for dark energy, the mysterious force causing the expansion of the universe to accelerate, is that it might be vacuum energy. Think about that. The fate of galaxies, the long-term future of stars, the ultimate shape of space-time, might be governed by the energy of what we used to call nothing. But there's a problem. When physicists try to calculate the energy of the quantum vacuum using our best theories, they get a number that is absurdly, catastrophically wrong, off by something like 10^120. That's a 1 with 120 zeros after it. It's been called the worst prediction in physics. Somewhere between the math and reality, something doesn't add up. Either our understanding of the vacuum is incomplete, or the void is hiding a secret we haven't even learned how to formulate yet. The fact that nothing refuses to behave is, in itself, one of the greatest mysteries in science. Now let's tilt the file sideways and look at an even stranger idea. What if the void we live in is not the best possible void? Some physicists talk about something called a false vacuum. Picture the vacuum not as the lowest valley in a landscape, but as a marble sitting in a small dip on the side of a hill. It feels stable. It doesn't roll. But a deeper valley lies further down. If the quantum vacuum of our universe is only metastable, not truly at the lowest possible energy, then in principle, it could tunnel into a more stable state. Translated into less terrifying terms, the very fabric of reality could, one day, decide to reconfigure itself. A tiny bubble of truer vacuum could form somewhere in space. If that ever happened, the bubble would expand at nearly the speed of light, rewriting the laws of physics as it goes. Every atom, every star, every memory, every equation, every story, redefined or erased in a front of unstoppable nothingness that is something else. You would never see it coming. One moment you exist under one set of physical laws. The next moment, you don't. This scenario is deeply speculative. Many things suggest we might be safe, at least for longer than the Earth and stars will exist. But whether or not it ever happens, the possibility itself teaches us something chilling and profound. Even what we call empty space is part of a cosmic decision, a choice, frozen into the structure of reality. Our universe is the result of that choice. The void is not just where things happen, it is how things happen. Now let's widen the frame again. We've treated the void as one thing, one universal background. But what if there isn't just one? Some models of cosmology suggest the possibility of a multiverse, not just many planets or many galaxies, but many universes. In some of these ideas, each universe has its own vacuum, its own version of nothing, different physical constants, different particles, different kinds of space and time. In this view, our vacuum is just one patch in a much larger fractal of reality, a single bubble in an infinite cosmic foam. From inside our bubble, the void feels universal and absolute. From the outside, if an outside even makes sense, it would be just one environment among many. Imagine a library filled not with books, but with vacua. Each book is a universe. Each page is a history. Most of them will never be opened, never be read, never host a single conscious mind to wonder about them. And yet there they are, possibilities frozen into the architecture of existence. Maybe in that larger structure, our void is not special at all. Or maybe it is incredibly rare, a vacuum whose laws just happen to allow atoms, chemistry, stars, and brains that ask annoying questions like, is the void really empty? If that's the case, then the void is not just a background, it's a filter, a selection effect. We are here because our version of nothing is unusually good at producing something. Let's bring this back to you, sitting wherever you are right now. Between your atoms, there is mostly empty space. If the nucleus of an atom were the size of a marble in the center of a cathedral, the electrons would be like gnats whizzing around near the walls. Everything you touch, everything that feels solid, is mostly void held together by fields and forces. The chair beneath you, the walls around you, your own body. You're not just surrounded by emptiness, you are built out of it. The solidity you feel is the result of quantum rules that forbid certain particles from occupying the same state, and electromagnetic forces that keep atoms at arm's length. From one perspective, matter is like intricate origami folded out of vacuum. The paper is the void, the shapes are us. And if you zoom in even closer, beyond atoms, beyond quarks, beyond any currently known scale, you still find fields, patterns in something we no longer have ordinary words for. The void is not a blank page, it is the paper factory, the conditions that allow the page to exist at all. Now let's take a small detour into fantasy. Not because it's untrue, but because sometimes imagination is the best telescope we have. Close your eyes and picture a civilization unimaginably advanced, living in a universe much older than ours. Stars have grown scarce. Galaxies are dim embers scattered across a cooling sky. To survive, this civilization has learned to harvest the vacuum itself. They build machines the size of solar systems to tease usable energy from quantum fluctuations, pulling order out of the restless background. To them, planets and stars are no longer the main resource. The resource is nothingness. Their cities are built in the shadows of black dwarfs and dead stars, powered by subtle differences in vacuum states, like water wheels turning in almost still rivers. Eventually, as the universe continues to cool and stretch, even that becomes difficult. The void flattens toward uniformity. Differences in temperature fade. Entropy wins. In their final age, the last minds of this civilization may spend their remaining energy simulating the past, replaying the eras of starlight, rewatching the young universe where galaxies blazed and questions like ours were first asked. And somewhere in those simulations, perhaps, there is a small blue planet, and a person listening to a voice talk about the void. From their point of view, we might be ghosts living inside a memory of a brighter time, etched into the structure of a fading vacuum. Is that true? There's no evidence for it. But the moment the void becomes dynamic, structured, and creative, these ideas stop being pure fantasy and start becoming philosophical probes, ways of testing what reality even means when the background is active. The void, once again, refuses to stay simple. There's another angle here. Not cosmic, not quantum, but deeply human. Emptiness terrifies us. We fear silence in conversation. We fear blank pages. We fear stillness, boredom, the unfilled calendar, the unanswered message, the room with no noise. We rush to fill every gap, with sound, with notifications, with people, with plans. Part of that instinct is survival. For most of our history, being alone in the dark could mean danger. But another part is a kind of psychological illusion. We equate emptiness with meaninglessness. If nothing is happening, we think nothing matters. And yet, almost everything meaningful in human life depends on space. Music is not just notes, it's the silence between them. Language is not just words, it's the pauses that tell you when an idea stops and another begins. Art is not just paint, it's the unpainted canvas that gives the colors shape. Even in your thoughts, insight often appears in the quiet moments when you stop forcing an answer. When you stare at the night sky and feel small, that feeling is not a bug. It is a feature. The void around us, the vastness above us, reminds us that our stories are tiny, but that they happen inside something enormous, coherent, and ongoing. The universe doesn't speak in words, but if it did, the void might be its punctuation, the pauses that make the sentence intelligible. In this sense, emptiness is not the opposite of meaning. It is what gives meaning room. Now let's pull all of these threads together, physics, cosmology, fantasy, psychology, and look again at our original question with renewed eyes. Is the void really empty? At the scale of human experience, yes, space looks empty. If you stand outside on a dark night, far from city lights, you'll see pinpoints of stars separated by yawning stretches of nothingness. At the scale of atoms, the void is perforated with particles, dust, neutrinos, and radiation. For every cubic meter that looks empty, the universe is quietly stuffing it with more structure than you can intuit. At the scale of cosmic structure, the void carves out giant caverns in the web of galaxies, gaps that are themselves threaded with dark matter and bathed in ancient light. At the quantum level, emptiness becomes an ocean of fluctuating fields, an arena where nothing produces forces, energies, and perhaps even the expansion of space itself. At the level of ultimate fate, the void becomes the main character, the enduring stage on which matter briefly flickers and then fades, leaving behind a universe that is more background than foreground. At the philosophical level, the void challenges our intuitions about existence, value, and meaning. It forces us to confront the fact that we are transient arrangements of not much, asking questions about everything. And at the psychological level, emptiness is something we project onto the world and then fear, when in reality, the gaps are often where life breathes. So no, the void is not empty in any simple sense. It is a sea of fields that never fully switch off, a reservoir of potential that births stars, galaxies, and perhaps minds, a sculptor of structure using gravity and expansion as tools, a mirror reflecting our fears and hopes about being small in a vast universe, a quiet engine humming beneath reality, slowly steering the fate of everything. When you look into the dark, you're not just seeing what's missing, you're witnessing the interface between what exists now and what might exist later. You're looking at a canvas that has already hosted 1 trillion stories and will host more, even if those stories are written by civilizations we'll never meet, or by fluctuations in a future so remote the human brain can't meaningfully picture it. The void is not the absence of reality. It is reality, stripped down to its most subtle form. So, as we finally, really this time, Close this dusty file. Take one more moment with the darkness. The next time you turn off the lights in your room or step outside on a starless night, remember, between you and the nearest star, there is a gulf of apparent nothingness stuffed with invisible matter, ghostly particles, fields that never turn off, and a fabric of space-time that itself is alive with possibility. Between your atoms, there is a similar gulf, a microvoid, humming with quantum rules that let you exist at all. You are a pattern temporarily carved into the void by the void itself, and that means that when you feel small or isolated or like you're floating in emptiness, you can remember this. You have never, not for a single moment, been in true nothingness. You have always been inside a universe that refuses to be empty. Thank you for opening this extended file with me tonight. And until next time, when you look into the dark, you are not falling into nothing. You are drifting through a universe where even the silence is full.